Hello everyone, my name is Devin Doring. I'm the Technical Services Supervisor for the City of Salem, Oregon in the US for the Public Works Department. My role is really focused on the GIS side of things for the department, as well as helping the department in digital transformation and innovation ideas, and most importantly, helping my city's department make good data-driven decisions. Today we're going to be looking closer at how Nearmap really helped document and answer some challenging questions regarding a large ice storm impact on our city's tree canopy back in 2021. Before I begin, here's the agenda. I'll begin with some background on our story on how we became a Nearmap customer. We'll talk a little bit about the ice storm itself and its impacts and our response to it. Next, we'll look at the impacts of the storm and some of the resulting questions that came out of it. And finally, we'll close with the benefits of this technology. My goal for this presentation is to leave you with a solid understanding of how the Nearmap environment and some simple GIS analysis can give you some powerful impacts and be able to give you some powerful answers to difficult questions. So the background, how did we become a Nearmap customer? Let me first start with what was our image strategy before Nearmap, and maybe this will sound familiar. Very routinely, we would get one capture of ortho imagery for our city, maybe every 3 years at best. It would be a complicated multi-agency contract where we would try to cost share, the amount. It was ultimately expensive, and to add insult to injury, you would have long lead times. So by the time you got the imagery, it was already 6 months to maybe a year out of date. Obviously, I realized this was not a sustainable solution. As important as imagery is to organizations and how much intel it gives you, you need a better method. So what were some of the things that really made us go to Nearmap? Well, for us, we get one capture a year. For some of you, it might be more. It's a single contract. It's cost effective, and it's essentially near real time. As soon as the imagery is processed, it's available for you to use. So overall, what we're seeing is this imagery as a subscription type model is a great model for an image strategy, and it works really, really well here at the city. And if you're not a Nearmap customer, I would highly recommend it. It's been great. So the storm, what happened? So back in February of 2021, the forecast called for some chances of freezing rain and snow. Nothing really atypical for us at that time of year, but the magnitude of this ice storm and what we would wake up to the next morning caught everyone off by surprise. That is ultimately if you could sleep through the night. I remember waking up in the middle of the night hearing branches crash and crack. It was very, very loud. You would also hear transformers explode, and I heard friends tell me that they got up in the middle of the night and they actually saw the explosions, the night sky light up. For us suburbanites, myself included, it was a little bit like waking up in a war zone. I'm not sure if that's completely fair, but it was pretty devastating. Trees down across roads, power lines down everywhere. This is one of my favorite pictures where you have a huge oak tree branch literally hanging in midair off of a power line. Ultimately, we had about 2 inches of ice accumulate on our on our trees, which had a huge impact. So ultimately, we had to immediately mobilize. This was a big event. Lots of different agencies responded to it. It was a joint venture. And ultimately, we relied really heavily on our GIS as an information management system to make sense of all of this information that we had to collect. We also got a sense very early on that the chances of this becoming a declared emergency by our governor was very high. And an emergency declaration really means that federal dollars can be requested and be available. But that also means that if you want to request that money, you're going to have to be working with FEMA, and they love paperwork. And if you worked with FEMA before, the name of the game is documentation. They want to see what things were before the damage, after the damage, and then your efforts at mitigation to fix the damage, all along the way at all these data points, answering the questions who, what, where, when, why, how. Overall, and I think these numbers are probably a little bit out of date, but to give you a sense of the scale, we had crews do about 2,400 service requests, 4,600 different damage assessments, 3,400 work orders, and just 500-ish just ad hoc work orders of people finding, or field crews finding things in the field and addressing that as they find it. As we started to come out of the response phase and go into the recovery phase, immediately the number one question is, how was the tree canopy impacted? And then different AOIs, different areas of interest. So depending on who you were, if you were, an internal staff member or a city council member or the public, you were kind of interested in different areas. How is the canopy impacted throughout the whole city or my ward or in the parks? A big one was the stream corridors. Our stormwater crew, they concern themselves with the MS4 permit, which is our stormwater permit, and they have to look closely at stream temperatures, and the tree canopy has a big part to play in that. So lots of different stakeholders pretty much asking the same question, but just for different areas. So how do we go about answering, a question like that? Well, thankfully, for us, we had existing tools. We knew that we were going to use GIS, and we knew, being a new Nearmap customer, that it was going to be an integral part of answering that question. And basically what we wanted to do is what's called a change detection analysis. And you can think of change detection as simply comparing a before and after state. Now for us, we were concerned with tree canopy, but this could apply to really any number of events, whether it's forest fires or flooding or earthquakes or tornadoes or whatever. I mean, if you can see the impacts in the imagery, you can do some sort of change detection analysis. But again, for us, it was the ice storm, the tree canopy itself. So you really need three things. You need a current area of interest. These are shapes defining the where, right? The where do I want to do this analysis, whether it's city limits or the parks or the stream corridors. You have to have those areas defined. And then you need the data, basically polygons representing the tree canopy before the ice storm and data representing the tree canopy after the ice storm. So where are we going to get this data? And I immediately thought of the Nearmap AI packs. Now at the time, these were fairly newish, a newer product, but I knew that they had tree canopy, and so I immediately started bugging our account manager, like, hey, can you get me tree canopy data for the prior year and the capture after the ice storm, so I can do some analysis. And Nearmap hooked me up, and we were able to put together this analysis to answer these questions. So where do you find these AI packs? Just simply, if you're looking in the Nearmap map browser, if you look on the left-hand side, you'll see a data layer sort of area. And if you don't see anything, talk to your account manager. I'm sure they can turn it on for you, so you can investigate all these different layers that are available, and they're adding more all the time. So we have our data. Now, how are we going to go about analyzing this? How are we going to go about making sense of the before and the after? So as I mentioned, you're going to have some sort of data representing your before state. So here on the slide, the before storm canopy. And then you're going to have another layer for your after storm canopy. And then you're going to have some sort of intersection between the two areas that are common to both areas. And essentially, to do a change detection analysis, you have to break these shapes down into their three corresponding parts. So how do you do that? In every GIS software, whether you're using the Esri platform or other open source solutions, these are all available. These are very, very common tools. In order to get your before and after, your pink and your green areas, you're going to use a tool called the erase tool. And it does essentially exactly as it says. It uses one shape to erase the intersecting component of the other. So you're left with just the pink and the green. To get the blue, you're going to use a different tool called the intersect tool. And basically, again, it does exactly as the name implies. It intersects or gives you the shape that's common to both. And that's exactly what we did. So if you look on the picture here, here is just a random sampling of the city. This is a Nearmap image of 2020 overlaid with those different polygons that I was talking about. And I want you to really focus on the pink areas. The pink areas are where we were saying or seeing the canopy basically gone in the 2021 imagery. So if I toggle back and forth, you should see that. And again, really focus on the pink areas. As I go back and forth, you should really see that the algorithms did a great job of finding our tree canopy, and our geoprocessing tools did a very good job at segmenting these different shapes. So that's step one of the analysis. What's step two? Well, now you basically need to do some math, and the tool to use this is called Summarize Within. And again, this is common in most GIS software. I'm pretty much just going to use Esri's description because I think it does a great job of really summarizing what this tool does, no pun intended. But basically, in simple terms, it takes two layers, the input summary features, or the things that you're wanting to count, and the input polygons, which are the areas of interest, and stacks them on top of each other. And after stacking these layers, you look down through the stack and you count the number of input summary features that fall inside the input polygons. And then you can calculate simple statistics like the sum, the mean, the min, the max, and the result is these enriched polygons that have statistics about those summary features. So for us, using polygons of tree canopy, we use the last one. We're summarizing polygons within polygons. But this tool works too for points and lines. So after the analysis and you get these results, you start thinking about, well, how am I going to present all this information, this this data. And we have some very talented GIS analysts, and we thought the best way to do this is really to make it as public as we can in a dashboard where people can self-serve, find the data for themselves. We believe very strongly in open data. We want people to see it, and play with it. It has some other benefits too, in that it reduces staff time in responding to other inquests or phone calls or emails, when they can just say, hey, go check out this app. Like, it has it all there. You can play around. It's got all the summary statistics. So having all of this analysis in a digital format enables very, very easy communication to the public and to stakeholders. Another benefit was we were actually able to answer the question. Thinking through it, I don't think there is any way that we could have done this analysis without Nearmap. As your area of interest increases, as you're trying to understand impacts of certain things, and your areas start getting very, very large, such as at a city, a county, or a state level, you really, really have to go to remote sensing. There's really no other technology that exists that can help answer these big questions. Smaller, areas of interest, maybe at a single park size or smaller, you could maybe do something with a drone or maybe use manual inspections. But relying on Nearmap and their capabilities and their coverage gets you able to ask big questions about big areas, which is very, very difficult to do. Finally, the other benefits of really this analysis and doing this exercise was it really helped maximize our federal FEMA reimbursement. Using tools like GIS and the Nearmap AI packs, I was hearing rumors that it started to get to a point where FEMA just stopped asking for proof of documentation because they knew we had just essentially captured everything, and that we were just able to hand off this entire ecosystem documenting the before state and the after state. And so in a lot of ways it helped alleviate the documentation burden. And I'll leave you kind of with an adage. You've heard that a picture is worth 1,000 words. For us, it's actually worth more like $5.3 million, because that was our maximum federal reimbursement amount, and we were able to get that. And without these types of platforms, without these types of data to help you look closer and make you smarter in your inferences, I don't think there would be a way to do it. So with that, I want to thank you very, very much for taking the time to listen to my presentation. My email is up there. If you want to email me any questions, I'd be more than happy to reply to them. If you want to actually take a look at the application we published in the last slide, you can scan the QR code, or there's a tiny URL there as well. With that, I hope you enjoy the rest of your conference, and thank you for looking closer at digital transformation of the tree canopy. Thanks.